Hello everyone, how are you? I'm fine here and I hope you all people are fine in this pandemic situations. In today's session I am going to address three problems that have been posted in our group e-PCM 2077. The questions were posted by Vivek Pandey, Parikshit Adhikari and Santosh Bista. Out of those three questions, one question is from physics and another two questions are from mathematics. So let's move towards those questions one by one. The first question is posted by Vivek Pandey. As you people can see the question in this upper part of the video. The question is actually asked by Vivek Pandey and the question is integration of x sine inverse x with respect to x. So while using integration by parts, we have to know that the order of the functions that should be taken as first function and the second function while performing the integration. Inverse functions are usually the first priority function in integration by parts. First inverse, the second priority should be given to logarithmic, third priority should be given to algebraic function, fourth priority should be given to trigonometric function, and the last priority should be given to exponential function. And as sine inverse x is inverse functions, so it gets the first priority and sine inverse x act as u, whereas x acts as v. So we have integration by parts as integration u v dx is equal to first function integration of second function minus integration of derivative of first function integration of second function, and again this will act as integral function for the second part. So taking u as sine inverse x and b as x, we can directly write first function integration of second function minus integration of derivative of first function integration of second function, and this in turn acts as integral function for the second part. So into integration of x with respect to x will be x square by 2 minus integration derivative of sine inverse x with respect to x yields 1 upon 1 minus x square, and integration of x with respect to x yields x square by 2. So our functions will be taking this 1 by 2 common, we will get x square divided by square root of 1 minus x square dx. So here we have to use the substitution method. That means when you people see the functions 1 minus x square in the square root functions, then we have to think that this can be substituted in the form of 1 minus sine square theta to simplify the problem. So in the second part of the first part is completed, and the first part of the integration by parts itself is completed, and second part we have to perform the substitution method. That means put x equal to sine theta, so dx will yield cos theta d theta. That means 1 by 2 x square sine inverse x minus 1 by 2 for the second parts. So x square will become sine square theta 1 minus sine square theta, and dx will become cos theta d theta. So 1 by 2 x square sine inverse x minus 1 by 2 sine square theta. So 1 minus sine square theta will be cos square theta, and square root of cos square theta will yield cos theta. That means this cos theta and this cos theta gets cancelled. And these functions can be arranged as 1 by 2 1 minus cos 2 theta will yield what? 2 sine square theta. To make it sine square theta, we should divide this by 2. So 1 by 2 x square sine inverse x. So let's separate this term. So 1 by 2 times 1 by 2, 1 by 4. Minus 1 by 4, integration of 1 times d theta is simply d theta. So minus minus will result into plus, and 1 by 4, so cos 2 theta d theta. So this will become 1 by 2 x square sine inverse x minus 1 by 4, so integration of d theta will yield theta only, plus 1 by 4, and integration of cos 2 theta with respect to d theta will be sine 2 theta by 2 plus c. So substituting value of theta from this assumption or this substitution expressions, we will get 1 by 2 x square sine inverse x minus 1 by 4. What is theta? Theta is simply sine inverse x, and this will become 1 by 8. So sine 2 theta is, we can write 2 sine theta cos theta plus c. So this will become 1 by 2 x square sine inverse x minus 1 by 4 sine inverse x plus 2 4 is 8, 1 by 4. So what is sine theta? X times what is cos theta? So from x equal to sine theta, we can write cos theta is 1 minus sine square theta, that is x square plus c. So this is our required answer for this problem. This question is a little bit lengthy from the perspective of entrance examination, but it is good questions and can be useful for +2 examinations. So overall this question is a bit lengthy, but it is good. So now let's move towards another questions that has been posted, and that has been posted in our group by Santosh Bista. So you people can see the question in this upper part of the video, and it tells us to find the value of square root of minus 2 plus 2 times square root minus 2 plus 2 times minus 2 plus, and this will advance towards infinity. So let y is equal to minus 2 plus 2 square root of minus 2 plus 2 square root of minus 2 and so on up to infinity. If you closely look this expression, then we suppose y equal to square root of minus 2 plus 2 times square root of minus 2 plus 2 times square root of minus 2, and this term advancing towards infinity. So from this expression minus 2 plus 2 times this expression, again the initial expression is repeated. That means we can directly write this expression as y is equal to minus 2 times 2y. Are you getting this? Because y is square root of minus 2 plus 2 times square root of minus 2 plus 2 infinity. So here we have suppose the expression y. So now solving for y is the value of this function. So squaring both sides, we will get y square is equal to minus 2 plus 2y, or y square minus 2y plus 2 is equal to 0. So this is a quadratic equation, but it is not a perfect square or cannot be factorized in terms of real roots. So we can apply quadratic equation formula solving with x equal to minus b plus minus root b square minus 4ac by 2a. We will get y equal to minus 2 plus minus 2 square minus 4 times 1 times c, here is 2, and 2 times a. So 2 plus minus, what is this? Minus 2 square will be 4, and 4 to the 8, 4 minus 8 will be minus 4 by 2. So 2 plus minus square root of minus 4, in fact it is 4i square, so square root of 4i square is 2i by 2. So dividing this numerator by denominator, we will 1 plus minus I. So y equal to 1 plus minus y. Remember what we have supposed for y. So y is this. So minus 2 plus 2 root minus 2 plus 2 root minus 2 to infinite is equal to what? 1 plus minus I. So this is a little bit tricky question. Such types of problems are also encountered while facing derivative problem, because same terms are repeated over and over. So we can assume initial functions or initial algebraic expression is x or even y, and then again incorporate that x or y in the advancing expression. So this will be the answer for this second question. And let's move toward the third question, which is asked by Parikshit Adhikari and is from physics and is actually from electrostatics section, and is asked from the capacitor part of the electrostatics. So let's move toward the third question. So our third question is, you can, as you people can see the question in upper part of the video, it tells us how many capacitor each of 8 microfarad and 250 volt are required to form a composite capacitor of 8 microfarad and 1000 volt. Remember, the main point is a rating of one capacitor is 8 microfarad and 250 volt. Rating of resultant composite capacitor is what? Again 8 microfarad and 1000 volt. For solving these type of questions, we don't have direct formula, but we have to think and decide for the exact pattern or combination of capacitor. First of all, let us start with voltage. As composite capacitor has total withstanding voltage of 1000 volt, whereas one single capacitor can withstand 250 volt. Remember, when we connect capacitors in parallel, then the voltage across them remains same for identical capacitor. So if one capacitor has voltage of 250 volt, then to obtain 1000 volt, that means higher voltage. Whenever higher voltage is required, we prefer we don't say like we prefer, so we must go for what? Series circuit, because in series voltage gets added and the resultant voltage will be higher than the individual voltage. So I am just writing that if we have to obtain the total voltage of 1000 voltage and we have just single voltage of 250, then I need 4 sections. I don't know how many capacitors are present in one section, but what I know is I must have 4 sections of capacitor. I must have 4 sections of capacitor in which individual sections can withstand 250 volt, and these sections are connected in series. Because if these sections are connected in series, then overall voltage that will be withstand with the help of this composite capacitor will be 1000 volt. So the criteria for withstand voltage is met. However, we also have to calculate the expression satisfying the capacitance of the composite capacitor, that is 8 microfarad. As identical capacitors are used, so for 4 identical capacitors connected in series, remember, if I say 4 identical capacitors connected in series, then you people might get confused. So let's say for 4 identical sections to give, let's say this is section 1, this is section 2, this is section 3, and this is section 4, and these are identical sections. If I have to get 8 microfarad from series connection of these 4 identical sections, tell me what is the equivalent capacitance in section 1, or we can say what is the equivalent capacitance in each sections, because we know in series C equivalent is equal to C by N for n identical capacitor, but I am here talking about n identical sections. So if I have to obtain 8 microfarad as capacitance of composite capacitor, and I replace this C as C section because I have total 4 sections in series, then equivalent capacitance in one section will be 32 microfarad. So now what I have to think is, how can I get 32 microfarad in each section? Because I have no capacitor with capacity of 32 microfarad. I have lots of capacitor with capacity of 8 microfarad. However, I know that if I have capacitor of capacitance 8 microfarad in large number, then I can get 32 microfarad remaining 32 microfarad, keeping voltage same. In which way? It is simple. When we connect 4 parallel capacitor, 4 identical parallel capacitor, then capacitance gets multiplied by 4, whereas voltage remains same. That means, so I should have 32 microfarad here, 32 microfarad here, 32 microfarad here, and 32 microfarad here. This will only result into, so 32 divided by 4 is equal to 8 microfarad. So I can, for one section, it is one section, the capacitance of one section. So for one section, I can arrange these capacitors as this way. It is simple, because 8 microfarad 250 volt, 8 microfarad 250 volt, 8 microfarad 250 volt, 8 microfarad 250 volt, 250 volt will result into what? 32 microfarad, but voltage remains same in parallel, 250 volt. So this will give 32 microfarad and 250 volt here. Another section of 4 capacitor in parallel give 32 microfarad and 250 volt here. Another section containing 4 identical capacitors will give 32 microfarad and 250 volt here. And another section will also contain 4 identical parallel capacitors of each 8 microfarad 250 volt to give 32 microfarad and 250 volt here. So we can say that now if there are 4 capacitors in this section, another 4 here, another 4 here, and another 4 here, then total capacitors will be 16. Total capacitors required will be 16. So for this combination, we require total capacitors each of 8 microfarad 250 volt is equal to capacitor in one section times number of section. That is, capacitor in one section is how much? 4. We have just studied that. And number of sections for 1000 volt, we have 250 volt from one section. So to get 1000 volt, we have to connect 4 sections in series, because voltage gets added in series. So number of sections will be 4. So total required capacitors will be 16, which is total required capacitor will be 16, and which is our required answer. So this type of problem in fact are very important for entrance examination, but these types of problems are very lengthy while describing the conceptual part. But if you think and practice one or two types of such problem, then it will be very easy, because the main point you have to think is that how can I get the composite voltage from the individual voltage. That is generally when the composite voltage is greater than the rating of individual capacitor voltage, then we have to go for series section. From there we get how many sections should be put in series, and to get the exact capacitance, we have to perform certain series parallel analysis, because in case of identical capacitor in series, capacitance gets reduced. So in the same way, if we have 32 microfarad, 32 microfarad, 32 microfarad, 32 microfarad in 4 sections in series, then the resultant will be 32 divided by 4, and which is eventually will be 8 microfarad. So we have to think critically in this type of problem. But these types of problem are very good to exercise your brain. So these 3 questions, I think these 3 questions are addressed now, and many more questions will be addressed in coming time. That will be promised from my side. For those questions which get no solutions and are posted in our group, will surely be addressed from my side. At last, please visit my channel for some solutions of the questions whose solutions are not posted in our group. And please don't forget to subscribe my channel, and don't forget to tell your friends to subscribe my channel, because many more things are coming in this channel in coming period. Okay, thank you all.